Okay. On my final exam, the average is usually about 75 with a standard deviation
Can you move the paper down?
Yeah. Okay. On my final exam, the average is usually about 75 with a standard deviation of, let's say, 8. We randomly select a student at random. We randomly select a student. Let me tell you what the question is. So my average from past experience on the final is 75 and the standard deviation is 8, guys. If we select one student at random, what is the probability that this student is going to score more than, let's say, 82 on the test? What is the probability that the student will score higher than 80? Let's say 80. You guys, this is a legitimate question. You know my average is 75 usually. Standard deviation is 8. What's the likelihood that you will get more than 80? What's the probability? What's the chance? So let me show you how to do this. And I'm going to show you how to convert this to a problem, you know, just then that we can solve using the calculator and using the formula that I introduced on the calculator. Since this is a probability, guys, so we need the probability of, that is how you interpret this. It's not, I'm not talking about z-scores here. I'm talking about x values, raw values. The mean is not 0 and the standard deviation 1. So mean of 75 and standard deviation of 8. So it's not z, it's x. So we need the probability of x more than 80. You learned how to use the calculator, guys, to find the probability of z greater than 1.5. You put a lower bound, you put an upper bound, you put a mean, you put a standard deviation, 0, 1, and then you answer the question. But now it's not with z, it's with x. But I'm going to show you guys it's not going to be any different. So the first way I'm going to solve this problem, I'm going to show you how to use the calculator to solve this problem. So let me just bring the calculator. And I'm going to go to second distribute, Normalcdf. All right. Let me sketch this for you guys. I'm not going to put 0, 1 because he gave me a mean of 75 and a standard deviation of 8. So 3/8 here and 3/8 there. And we need the probability of x greater than 80. So it will be, if I add 8 here, it will be 83. If we'll add 191, and that's 99. Greater than 80, guys, will be this area. Okay. If you are to use the calculator to solve this problem, what would be your lower bound? Remember, this is an x line, and we need to go, this is x equals 80. We need the score to be higher than 80. What's the probability that the score is higher than 80? What lower bound would you choose here?
80.
80. What would be your upper?
1,000,000.
1,000,000 or 1,000,000,000. The sky is the limit. What's your mean? That's the only difference between z and x. we have a mean and we have a standard deviation. It's not a probability of z, it's a probability of x. So you have to put the raw mean and the raw standard deviation. What's the mean here, guys?
75.
75. What's the standard deviation? 8. And then paste. You see the difference, guys? Instead of the 0, 1, you just put the actual mean and the actual standard deviation and then hit enter. And that's that chance. So the answer is 0.2660. So there is, change it to a percent for me, guys. What would be the percent? 26.
26.60.
So if someone asks you, what's the chance that someone will get over 80 in Mr. Bazzi's class on the final exam, you tell them that it's 26.6% chance, which is very good chance. So to score over 80, not to pass that test, to score over 80, get 85, 86, 92, 93, up to 100. The chance is 26.6%. So this is how we use the calculator. Now I'm going to take you back to static crunch and show you. Okay, see what you have to change. You have to put the actual mean and the actual standard deviation. The actual mean is 75 and the actual standard deviation is 8. And we want standard here. And we want it greater than 80, a score of greater than 80. And remember, the answer was 0.266. Let's see if we're going to get the same thing. There you go. It's the exact same answer. 0.266 if you round to 3 decimal places or 4 decimal places. It will be 0.266. You don't keep this as 0 and 1, as I told you guys. So it has to be the actual mean. So when you work with X values, the actual values, not the standard Z scores, you put the mean, whatever the mean is and whatever the standard deviation is, and you solve the problem. And that's how we solve this problem. So you got static crunch using the normal calculator, or you got the normal CDF on your TI84. Now, let me show you how to do this one by hand. Any idea, guys? How would you do this by hand? You only have table 4. When I say by hand, using table 4. Let's say you don't have access to technology. The internet is not working. You don't have batteries in your calculator and you want to solve this problem. And we need the probability that the students will score higher than 80. So you put the probability of X more than 80, and you only have table 4 to solve this problem. What would you do, guys? Any ideas? Let's brainstorm here.
Can you change it to a z-score or no?
Very good, excellent. You couldn't just look up 80, guys, in the table here. You're not gonna find it because 80 is not a z-score. You have to change 80 to a z-score. Remember, this is a table of z-scores, so you need to change the value to z-score. Exactly. Look, the highest that you can get with z-score is negative 3.49. You cannot go beyond negative 3.49. If you get a z-score more than this, you just use the highest here, because over 3 is very, very unusual, guys. So that's why this table goes up to negative 3.5 only. So excellent idea. We need to change 80 to a z-score. So change 80 to z-score. So z will be the value, which is 80, minus the mean, which is 75, divided by the standard deviation, guys, which is 8. There will be 5 over 8, which is 0.375. Usually z-scores, guys, we have to round it to 2 decimal places only. So that will be 0.38. Now watch. My question will change. from finding a probability of X more than 80, I'm gonna change it to a Z question. It will be probability of Z bigger than 0.38. Now, I'm not saying that you have to do it this way, guys, but this is another way. I'm not gonna be showing this too many times, just a few times, but I will be focusing on the TI84 mainly. Okay, now I can go to the table and show you what the answer is. Remember, this is a greater than, that means area to the right. The table doesn't do area to the right. So whatever I get off the table, I have to subtract from 1. So it's a lot of work doing it by hand. 0.38, guys, watch. Uh, 6480. All right, so we have 75, 80 minus 75, 5 over 8. Yeah, 38. 6480. So it will be 1 minus 0. So probably I read this wrong here. It should be 36. They should match. The two answers should match, guys. Or I put something wrong in the calculator there. I'll double check. So 1 minus 386480. Yes. And then you just subtract and you get the answer. 1 minus 0.64. Oh, 5 over 8. I made a mistake. It's me. 5 over 8 is not 0.375, guys. Nobody corrected me on this. It's 0.625. Sorry. I was wondering, there's no match between the two answers. That's impossible. They should match. So it will be 0.63 here, guys. And now we need to change the answer. 0.63. Yeah, now that makes sense. 7357. So it's 1 minus 0.7357, which is, that should match with the one above, guys. 1 minus 0.7357, 2643. There you go. Which is almost a perfect match. The reason why they don't match perfectly because we rounded this one. So, but when you do your work online, the system is designed to accept answers, whether you use a TI84, whether you use StatCrunch, or you do it by hand. So there is a margin of error that will be accepted when you do your work online. So this is how we do this problem using StatCrunch, TI84, and by hand using table 4. Okay, we're gonna go and do this exercise together, guys. Now let me just see. Yeah, right here. Okay, have your calculator handy, and we're gonna show you how to find probabilities for normal distributed variables using a table and using technology. I'm gonna focus on technology from now on. If a randomly variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve. So he wants a probability of x less than 600. You have a mean of 500 and a standard deviation of 100. Okay, guys, before you flip to the next page, let's do it together here. So second, distribute, second and quit, distribute Normalcdf. Okay, guys, what would be the lower bound for this question here? Less than 600, so from 600 and below. Remember, when I say less, what do I start with the lower?
Negative.
Yeah, very good. Always less than, start with a negative. And then what's the upper? Upper is the right wall of the number.
100.
600. Your mean, guys, is 500. And your standard deviation, you see, we're not using 0, 1 because we're dealing with X now, not Z. And get the answer, paste, done. There you go. The answer is 0.8413. And here's how I would like you guys to express this answer. If I ask you to show your work on an assignment, here's what I expected from you. So you will write probability of X less than 600, and you will put equal normal CDF, and you will put the 4 arguments, -1,000,000, you put 600 as an upper fence. You can blow it lower fence, upper fence, mean, and a standard deviation. And then you get the answer, which is 0.8413. If he says, write your answer as a percent, you can write it, guys, as 84.13%.
Can you move the paper up just for a second?
Sure, there you go. All right. I will share this handout with you guys as well once we're done with it. So remember, this is X. When it is Z, you must have 0, 1 in here. When it is not Z, it's X, you must have the actual mean and the actual standard deviation. That's the difference between X and Z. Okay, you notice, guys, if I show you the work here, I did show you the work, how to convert it to a Z-score, but you don't need to convert it to a Z-score. You can just find, you can use technology. Okay, let's do exercise 5 together. A survey indicates that people use their cellular phones on average of 1.5 years. So the mean is 1.5 before buying a new one. The standard deviation is 0.25. That's sigma, guys. So it's not 0, 1. We're talking about X. A cellular phone user is selected at random. What's the probability that the user will use their current phone for less than 1 year before buying a new one? This is a very interesting question, guys. We know on average people use their phone of 1.5 years, 1.5 years, with a standard deviation 0.25 before investing in a new one. What portion of phone users buy a new phone before 1 year? So after they had their phone for less than 1 year, what's the likelihood? So that's a good question to find out. What percent of people are gonna go and buy a phone after having the phone for less than 1 year? I would be interested to find, you know, just what proportion of people would be doing this. So let's find, let's do the answer here. Okay, so we need to change this one to a probability question. So you do P, you put X, what he wants. Okay, what's the sign that he wants, guys? What would be the sign?
Less than.
Less than. You need to know that. That's very important. Exactly, less than 1 equals. I'm gonna write, you know, just the math here, and then we'll do it on the calculator, normal CDF. Okay, guys, I'm here. What's the lower bound?
-1,000,000.
-1,000,000, a trillion. Just put it. What's the upper fence? 1. You guys agree it is 1? What's the mean? 1.5. And what's the standard deviation? 0.25. And let's see what the percent is. I'm curious to know. I did this example before, but I forgot what the answer was. So we're gonna go second, distribute, normal CDF, You don't, again, we don't use normal PDF, CDF only. Negative a million or 10 million here, then 1, then the mean is 1.5. It's going to be a small percent of people probably. And then sigma is 0.25 because those phones are very expensive. Paste. Here you go. That's the answer. 0.022. Okay, I want to round to 4 decimal places. What would be the answer, guys?
0.0228.
Correct. That is the answer. Change it to percent. 2.28%. So if we know on average people use their phone for 1.5 years with a standard deviation of 0.25, what's the likelihood that a person buy a phone before using it for 1 year? It's only a 2.28%, and this is called unusual. Unusual. Any answer that is less than 5%, guys, it's called unusual. I'm gonna write it down here. Unusual event when probability is less than 5%. All right. Let's do
You
it.
said that was a standard rule that anytime
Anything less than 5% is unusual. Yes. In probability world, if you get an answer less than 5%, you can make a conclusion that this is an unusual event. Anything 5% or higher is called usual event. Okay, let's do exercise 6, guys, and see if we can do it. Please have your calculator handy, guys, and do it with me. I'm just showing you how straightforward those problems are. Now we're doing real world applications. When you see the X, it's a real life application. When you see a Z, we're just using the standard normal curve. So a survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes. So what's the label for 45, guys? What? Simple.
The mean.
Mean. You need to detect that. The standard deviation is sigma. The length of time spent in store is normally distributed. Normally means bell-shaped. All the work that we're doing, guys, based on we having bell-shaped curve. If we don't have a bell-shaped curve, this work will not hold. That wouldn't be valid. It's all based on the distribution is symmetric like this. And he say it is. Normally distributed means bell-shaped. A shopper enters the store. So we have a shopper who entered the store. We know on average people will spend 45 minutes at the store on average, plus or minus 12 minutes. Remember, a standard deviation 12 means it could be a plus 12 or it could be a minus 12. We have a shopper who enters the store. We need to know what is the chance that this shopper is going to be at the store between 24 minutes and 54 minutes. So you guys, I prepared already a hint for you to put here 24 and a 54. And would a student help me just fill in the blanks? Normal CDF. What are the 4 arguments going to be? First one.
24.
Yep. Next
That's
one.
54.
Next one.
45.
Yep.
Then 12.
Excellent. That's it. If you know how to input this, now go to the calculator and get it. And again, guys, if you don't have the calculator, download the link that I sent you. So you go second and distribute. Normal CDF. 24. 54. 45. And 12. You have to paste, guys. And now press enter. See, now the language that I put there, it's showing on the screen. It's 0.7333 if I do 4 decimal places. There you go. If he says what percent of the shoppers, you have to change this to a percent. So just be careful. Or 73.33%. B. What is the probability that you pick a shopper at random and this shopper will be at the store for more than 39 minutes? So would someone help me fill in the blanks here? So that will be what here? What number?
39.
Yeah. And that's going to be normal CDF. Okay. What would be the lower fence?
39.
Okay. What's the upper?
A million.
Yep.
And then 45. And then 12.
Exactly. That's it, guys. So let's do the calculator. So look, when you have a greater
I
than.
have a question.
Yes, go ahead.
When do we use the negative 1 million?
When it is a less than. So if this was a less than 39, you do a negative a million and then 39.
Okay.
If it is a greater than 39, you begin with 39 and then a million. And if it is in between, no worry about a negative a million or negative trillion. You just put the first number as a lower fence and the other number as the upper fence. So again, greater alone, your second one will be the million. Your first one will be just this number right here. Less than 39, let's say I ask you what's the probability of X less than 39. You do a negative a million, then 39, then 45, then 12. Okay, guys, so let's see what the number is. That's a good question. Second, distribute normal CDF. Okay, so we have 39 to begin with, million, but as big as you want, make the number, and then 45, 12. So I got 0.6914, guys. You can see that. Okay. One more here. C. We have 200 shoppers who enter the store. We want to know how many of those shoppers are going to spend more than 39 minutes at the store. That's something that you would be interested in knowing how much, so you can plan and how many cashiers, how many workers you're going to put on the floor, guys. So if 200 shoppers enter the store, how many of them would you expect to be in the store for more than 39 minutes? Any ideas, guys? Remember, we already figured out what percent of people will be at the store for more than 39 minutes. You did it in B. So what would you do?
Divided by 200.
Not divided. It is something like that, but it's not a division.
Would we change the 39 to 200?
No. You already figured out what percent. Okay, let me tell you, let me give you an example, guys, and probably you can answer this correctly. If I tell you I have 50 students in my class and 35% of my students are going to get an A, how many students will get an A? How would you figure this out? So I have 50 students and 35% of students got an A. How many students got an A? What do? You find 35% of what? Of 50. So you do 0.35 times 50, and then you can figure out the number of students. And in part B, guys, you already figured out what is the probability that a shopper will spend 39. What's the percent? What's the likelihood that a shopper will spend more than 39? It was 69%. And if you have a 200 shoppers, what do you do with the 200 and the 69% to figure out, the number of shoppers?
Multiply them.
Multiply them always. It's a percent of the total. And you already have the percent, guys. So it's going to be 0.6914 times 200. And then let's see. Definitely for shoppers, guys, you have to enter a whole number because these are people. So I'll round it if I don't get the whole
If you
number.
rounded it, wouldn't it be 0.6915?
What was the probability? Let me see.
Because it was 0.69146.
Oh, was it? Let me see. Just 1 second. Yeah, you are correct. Good observation. So it will be, it's not going to impact the answer, but yes, definitely have to put the correct answer there. So 0.6915 times 200. 138.3. If this was a multiple choice, guys, you're not going to put 0.3, just put 138 shoppers. Okay, so this is how we solve probability questions using the TI84. If you were, guys, to do table 4 here, you have to change this to a z-score. And then after you change it to a z-score, you have to use the table. I'm showing you a way to avoid using this. You can use the TI84. That is fine with me. Or you can log into StatCrunch and use StatCrunch calculator. And I'm going to show you even something better, guys. Just 1 second. So I'm going to stop the recording here.